Hello everyone. So today we'll be doing some revision problems on probability of class 12th. Majority of the problems will be based on Bayes theorem and total probability. So let us start with a simple problem. So this is the first problem. Bag 1 contains 4 red and 5 black balls, while bag 2 contains 3 red and 6 black balls. One ball is drawn at random from one of the bags and is found to be red. So there are two bags and we are selecting one of the bags and we are drawing a ball, and we already got a red ball. Find the probability that it was drawn from bag 1. So the event which has already occurred, that is we got a red ball, that is taken as A. So let so we will be writing the events first. Let A is red ball is drawn, because we have already drawn a red ball, so that will be taken as A. Now this red ball has two possibilities, so that will be taken as E1. So that is it, we have selected bag 1 and red ball has come from that, so that will be first will be bag 1 is selected, then E2 will be bag 2 is selected. Now bag 2 is, now as per the question, see, if you see that we already got the red ball, what is the probability that we have selected the first bag? So we have to find A has already occurred and it has come from bag 1, so E1 given A. So this will be a problem of Bayes theorem. So that is P of E1. So if you use the formula P of E1, A given E1, then P of E1, A given E1 plus P of E2, P of A given E2. In all the problems of Bayes theorem, you have to find the partitions of the sample space. That is, here it is either bag 1 or bag 2, and A is the event which already has occurred. So now I'll try to find the probabilities and then we'll substitute in the formula. So P of E1, that is selecting first bag out of two bags, it will be 1 by 2. P of E2, that is also 1 by 2. Now P of A given E1. P of A given E1 means we are selecting first bag, then we are drawing a red ball. So if you see the first bag, there are 4 red and 5 black. So 4 red balls out of 9. So probability of getting a red ball from first bag is 4 by 9. Then probability of getting a red ball from second bag. So again, if you see the data, 3 red out of 9. So you just have to put all these values here. So once you put all the values and simplify, the answer will come as 4 by 7. So 4 by 7 is the required answer. Now to the second problem. It is known that 20% of the students in a school have above 90% attendance and 80% of the students are irregular. So past year result shows that 80% of students who have above 90% attendance and 20% of irregular students get A grade in their annual examination. At the end of a year, a student is chosen at random from the school and is found to have an A grade. What is the probability that the student is irregular? So there are two types of students, that is students are having more than 90% attendance and another is irregular students. And the probability of getting A grade for both of the categories are also given. So one of the student is selected at random and is found to have A grade. So that will be taken as event A. So A is the event, student getting A grade, student getting A grade. Now you will have to see the partitions, that is the two different categories of students. So that is student having above 90% attendance, student having above 90% attendance, that is the first category of students. Then second category is student being irregular, E2, that is student being irregular. Now come to the question. A student has found to have an A grade. What is the probability that student is irregular? So we will have to find probability of E2 given A. A has already occurred, so due to E2. So that is in E2. So because it's E2, so E2 will come in the numerator. A given E2, then P of E1, P of A given E1 plus P of E2, P of A given E2. So now let us try to find the probability values. After that we can get the answer. So here P of E1. P of E1 means students probability that student is having above 90% attendance is given that 20%. So it is 20 by 100. 20% are having above 90 attendance. So that is 1 by 5. So P of E2. P of E2, it is given 80% attendance. So it is E1 and E2 are partitions, or that means probability of E1 and probability of E2, if you add up, it should come as 1. So that first P of E1 is 1 by 5. So P of E2 is 4 by 5. Then P of A given E1. So what does that mean? A student who is having 90% attendance or above getting an A grade. So it's given here 80% of the students. So that will be 80 by 100. 80 by 100. So that is 4 by 5. And P of A given E2. P of A given E2, that is student irregular getting an A grade. So that is 20 by 100. So it is 1 by 5. So when you substitute all these values, the answer will come as 1 by 2. So 1 by 2 is the answer. Okay, now to the third problem. This is a case-based question from 2024 CBSE paper. So according to recent research, air turbulence has increased in various regions around the world due to climate change. Turbulence makes flights bumpy and often delays the flights. So assume that an airplane observes severe turbulence, moderate turbulence, or light turbulence with equal probabilities. Further, the chance of an airplane reaching late to the destination are 55%, 37%, and 17% due to severe, moderate, and light turbulence respectively. So on the basis of the above information, we have to answer the following question. Find the probability that an airplane reached its destination late. So there are three types of turbulence: severe turbulence, moderate turbulence, or light turbulence. And due to that, the airplane will reach its destination late. The probabilities are given. So here we will be taking A as the event, airplane reaching its destination late. Airplane reaching its destination late, that is A. Now due to the turbulence, different types of turbulence, this occurs, that is airplane reaches its destination late. So we'll take it as E1 as severe turbulence, then E2, it is given in the question itself, so we are just taking that only, moderate turbulence, and E3 is light turbulence. So now we'll come to the questions now. First question, find the probability that an airplane reached its destination late. So that is probability of A. So this is a question of total probability. So using the formula E1 there are three partitions here, so it will come up to P of E3, A given E3. Now let us write the probabilities. Probability of E1, so it is given that probability of severe turbulence. So here it is given severe turbulence, moderate turbulence or light turbulence with equal probability. So all the three are having same probability, P of E1, P of E2, P of E3 equal to 1 by 3. All are having equal probabilities. And now probability of A given E1. A given E1 means there is a severe turbulence and the probability that the airplane reaches its destination late. This is given 55%. So 55%. Then P of A given E2 37%, that's for moderate turbulence, and P of A given E3, that is 17%. So once you substitute the values in the formula, so that will give you the answer. The answer is will be coming as P of A, so it will be, answer will be coming as 33 by 100. So after the substitution, the answer will come as 33 by 100. Sorry, it is not 33 by 100, sorry for that. It is 109 by 300. So it cannot be simplified, so it will remain as 109 by 300. So this is the answer. Now if the airplane, the second problem, if the airplane reached its destination late, find the probability that it was due to moderate turbulence. So moderate turbulence is in E2, so airplane reached late, probability that it is due to E2. So that is using Bayes theorem. So probability of E2, probability of A given E2, then denominator is P of A, which we got in first part. So if you substitute the values, P of E2 is 1 by 3 into A given E2 is 37%, then divided by 109 by 300. So the answer will be 37 by 109. So this will be the answer for the second part. Now to the fourth problem. This is also a case-based question from the last year's CBSE paper. A shopkeeper sells three types of flower seeds, A1, A2 and A3. They are sold as a mixture where the proportions are 4:4:2 respectively. The germination rates of the three types of seeds are 45%, 60% and 35%. Based on the above information, answer the following questions. The first question is, what is the probability of a randomly chosen seed to germinate? And second, what is the probability that the randomly selected seed is of type A1 given that it germinates? So there are three types of seeds and the probability of the seeds germination, seeds to germinate are also given. So we will be taking A as chosen seed to germinate. What are the chosen seed to germinate? Germination is the main thing here, that is the event which has occurred in the second question also. So now what are the different types of seeds? That is the E1, E2 and E3. E1 is seeds of type A1 is chosen. Seeds of type A1 is chosen. Then E2 is seeds of type A2 is chosen. Then there are three types, so that third one will be coming as E3. E3 is seeds of type A3 is chosen. Now come to the first question. What is the probability that a randomly chosen seed to germinate? So probability of A. So again it's a question of total probability. So P of E1, P of A given E1 plus P of E2, P of A given E2, then plus P of E3, P of A given E3. Now we have to write the values or find the probabilities. Probability of E1, seed of type A1 is chosen. So here it is given, there are three types, they are solved as a where the proportions are 4:4:2. So that means the seed of type A1 is chosen is 4/10 because the ratio is 4:4:2. So that is 2/5. Now similarly P of E2 also 4/10, that is 2/5. The next is P of E3, that is 2/10, so that is 1/5. Now comes the percentage part, also it's given here. So P of A given E1, P of A given E1, so I'll be substituting here itself. It's 2/5 into, let's just see the percentage, 45%, that is the percentage for germination. 45%. P of E2 is 2/5 into the percentage is 60, then 35. So 60% plus 1/5 into 35%. So let us see the third one, 35, yeah, correct. So once you simplify this, the answer will come as 49/100. 49/100 is the answer for the first one. Now come to the second one. The seed has already germinated, so that is A has already happened. It is seed A1. A1 is the selected seed is A1, given that it has germinated. So that is P of E1, then P of A given E1 divided by P of A. That's the total probability already got in the first part. So P of E1, so it will be 2/5 into 45%, and the denominator is 49/100. So on simplification, this answer will come as 18/49. So 18/49 is the answer for the second part. Now the fifth problem. A coach is training three players. He observed that player A can hit a target 4 times in 5 shots. Player B can hit 3 times in 4 shots, and player C can hit 2 times in 3 shots. So this is the information given. So based on the above, answer the following questions. Find the probability that all three players miss the target. That's the first question. Find the probability that all players miss the target. Second question is find the probability that all of them hit the target. And third question, there are two parts. Find the probability that only one of them hits the target, and find the probability that exactly two of them hit the target. So what is the we have to write the probabilities of each here. So probability of A hitting, that is P of A, so it is 4 out of 5. Probability of B, that is 3 out of 4. Probability of C, that is 2 out of 3. Now first question is find the probability that all the three players miss the target. That is probability that all three players miss the target. So that means A is missing the target. So probability of A dash intersection B dash intersection C dash. Now all of them hitting the targets are independent events, so you can write it as P of A dash, P of B dash, P of C dash. So P of A is 4 by 5, so P of A dash will be 1 by 5, P of B dash will be 1 by 4, then this will be 1 by 3. So the answer to this will be 1 by 60. Now second question, find the probability that all of them hit the target. Find the probability that all of them hit the target. So that means probability of A intersection B intersection C. So that is P of A into A is hitting the target, B is hitting the target, and C is hitting the target. So all of them are hitting the target. So it will be 4 by 5 into 3 by 4 into 2 by 3. So that means it will come as 2 by 5. So that is the for the second question, it is 2 by 5. Now find the probability that only one of them hits the target. That is, you'll have to consider different cases. Only A hitting the target, then second case only B hitting the target, and third case only C hitting the target. That is the third question. Third question, A part, probability that only one of them hits the target. So there are three different cases. So when A is hitting, B and C should not hit. So B dash intersection C dash, that's the first case. Second, B is hitting, so A and B and C are not hitting. And third case, C is hitting the target, so that is A dash intersection B dash intersection C. Now if you substitute the values, so this will become 4 by 5, B dash and C dash, so that is B dash is 1 by 4 into 1 by 3 plus A dash is 1 by 5, B is 3 by 4 into C dash is 1 by 3, then P of A dash is 1 by 5, B dash is 1 by 4 into C, it is 2 by 3. Now if you simplify the values, the answer will come as 3 by 20. So the answer is coming as 3 by 20 for this A part. Now come to the B part. Find the probability that exactly two of them hit the target. That is, A and B are hitting the target, C is not hitting the target. So probability of exactly two of them hitting the target. So here also different cases to be taken. So first case, let us take A and B are hitting the target and C is not hitting, because exactly two should hit. Then A and C are hitting, B is not hitting. Then finally B and C are hitting, A is not hitting. So now if you substitute the probabilities, and when you substitute, that is probability of A is 4 by 5, then probability of B is 3 by 4, into C dash is 1 by 3, plus P of A is 4 by 5, B dash is 1 by 4, C is 2 by 3, plus A dash is 1 by 5, into B is 3 by 4, into C is 2 by 3. So that is just putting in all these values and substituting, the answer will come as 13 by 30. So this is the answer for the third. Now sixth question, airplanes are by far the safest mode of transportation when the number of transported passengers are measured against personal injuries and fatality totals. Previous records state that probability of an airplane crash is 0.00001%. Further, there are 95% chances that there will be survivors after a plane crash. Assume that in case of no crash, all travelers survive. So let E1 be the event that there is a plane crash, and E2 be the event that there is no crash. Let A be the event that passengers survive after the journey. So events are given in this problem. So we have to, this is also a case-based question. First one, find the probability that airplane will not crash. So that is, it's a very simple thing only, 1 minus probability that plane will crash. Plane will crash. So the probability of plane crash is given as 0.00001%. So 1 minus 0.00001%. So that is 1 minus 0.0000001%. So that will be 0.17 times 9, 0.9999999. So this is the probability that the airplane will not crash. That's 1 minus probability that plane will crash. Now come to the second one. Find probability of A given E1 plus probability of A given E2. So you have to understand this. A is event that passengers survive after the journey, after the plane journey. E1 means there is a plane crash. E2 means there is no crash. So when A is passengers survive after the journey, so they will survive without any injury. So here in case of no crash, all travelers survive. So the probability of A given E2 is 1. So all are surviving that. And for A given E2, there are 95% chances that there will be survivors. So when there is a crash, there is a chance that 95% survive. So the answer for this will be 1.95. Okay, we are adding the probability, so the answer is 1.95, that is 195 by 100. So this type of case based question, the first two questions are of 1 marks and the last one with option, this is options, that is of 2 marks. So we'll go to the third question now. P of A. Third question, A part. P of A is P of E1, A given E1 plus P of E2, P of A given E2. So P of E1 is, that is there is a plane crash, so 0.00001%. Then there are survivors, that is 95%. P of E2, that is there is no plane crash, 0.99999 into P of A given E2, that is survivors after no crash, that's 1. So if you the simplification is done for this one, the answer is coming as 999. So this will be the answer for this particular question. So it's slightly higher numbers, so please do verify the calculations. Now the second part, P of E2 given A. So we got P of A, so just applying the Bayes theorem, P of E2, A given E2, then divided by P of A. So P of A already we got, so P of E2 is 0.97 times into 1 divided by this particular number which we got in the first part, that is 98 times 5 divided by 1, 9 times. So again simplifying this, we'll be getting the answer. Okay, so this will be coming as the answer. So please do verify the calculation part. Now we are moving to the next problem. So a card from a well shuffled deck of 52 playing cards is lost. So a card is lost, and from the remaining cards of the pack, that is remaining 51 cards, we are drawing a card. A card is drawn at random and is found to be a king. So we already got a king when we are drawing that from the remaining 51 cards. Now what we have to do, we have to find the probability of the lost card being a king. So here again this is a case of Bayes theorem. So A be the event that drawing a red card, drawing a king from the remaining 51 cards. Okay, drawing a king from remaining 51 cards. After the cards is lost, then only we are drawing. Now E1 is lost card is a king, lost card is a king, and E2 is lost card is not a king, lost card is not a king. So now we'll move to the question and see what we have to find. We already got a king, that is, and we have to find that lost card is also a king. So E1 given A. Now you can write the formula, P of E1, P of A given E1, then P of E2, that is sum of the two. So I'll just written E2 first. P of E1, P of A given E1. So now let us find the probabilities. P of E1. P of E1 means lost card is a king. P, that is just like selecting a king card out of the total. So 4 by 52. That is 1 by 13. So P of E2, lost card is not a king. So there are 48 non-king cards. So 48 by 52. That is 12 by 13. Now probability of A given E1. So what does that mean? If lost card is a king, what is the probability of drawing a king card? So total will be 51. Out of that, number of kings also reduced by 1. So it's 3 by 51. So because number of kings are also reduced, because lost card is a king. So total is 51 in second case also. But lost card is not a king. So all 4 kings are there. So that will be 3 by 51 and 4 by 51 respectively. A given E1 and A given E2. So once you substitute and simplify this, so the answer will be getting as E1 given A will be 1 by 17. So that will be the answer to this particular problem. Okay, now the 8th problem. In a group activity class, there are 10 students whose ages are given 16, 17, 15, 14, 19, 17, 16, 19, 16 and 15. One student is selected at random such that each has equal chance of being chosen and age of the student is recorded. So age is, we are recording the age. So find the probability that age of the selected student is a composite number. So you just have to find out the probability that which are the composite numbers here. So 16 probability that 16, 15, 14, these are the composite numbers. So how many are there? So we'll count that 1, 2, 3, 4, 5, 6. So the answer will be 6 out of 10. So that is 3 by 5. So 3 by 5 is the answer for the first part. Now let x be the age of the selected student. What can be the value of x? So this is the random variable. So what can be the value of x? So that is 14, 15, 16, 17 and 19. So these are the possible values of x. So now in the third question it is asking to write the probability distribution. So x values are 14, 15, 16, 17 and 19. Now the probability of x, 14 there only one time, so 1 by 10, 15 2 times are there, so 2 by 10, then 16 3 by 10, 17 2 by 10, 19 2 by 10. So this is the probability distribution. So it is asking to find the mean also. So mean is sigma x into p of x. So when we multiply the corresponding value of x with its probability, so then we will be getting the answer. So 15 into 2 by 10 plus 16 into 3 by 10 plus 17 into 2 by 10 plus 19 into 2 by 10. So on simplification it will be coming as 16.4. 16.4 years is the mean age here. So that is the A part, probability of probability distribution. Now there is a B part here. So that is probability that age is a prime number, age is prime number given that age is greater than 15. So here, given that age is greater than 15, so that means prime number, and in that what is the probability at that getting a prime number given that greater than 15. So there are only three numbers here in the age. So out of 16, 17, 19, what is the probability of getting a prime number? So 17 and 19 are the prime numbers. So out of that, there's 2 are prime numbers. So the answer will be 2 by 3. That is the answer for the B. Now the next problem. Bag 1 contains 3 red and 4 black balls. Bag 2 contains 5 red and 2 black balls. 2 balls are transferred at random from bag 1 to bag 2. And then a ball is drawn at random from bag 2. So we are drawing a ball from bag 2 after the transfer. Find the probability that the drawn ball is red. So we'll be taking A as drawing red ball from second bag, red ball from bag 2. Now about the events, the possibilities. E1, that is about transferred balls. So 2 balls transferred from bag 1 to 2 are red. So both are red. And in E2, so again 2 transferred balls are black. And the third, there is one more case, that is 1 red and 1 black. 1 red and 1 black. So we have to find probability of getting a red ball. That means we have to find P of A. So this is also a question of total probability. So P of E1, A given E1 plus P of E2, P of A given E2 plus P of E3, A given E3. So now we'll write the probability of each. So P of E1. P of E1 means transferring 2 red balls. At random, it is written here, that means without replacement. It is just like selecting 2 red balls. So it can be done with the help of combination or with 1 by 1 also. If you write directly, it is 3C2 out of 7C2. 3C2 out of 7C2. There are 3 red balls. From that we are 2 are selected. Transferring means we are selecting only. So 3C2 upon 7C2, or can do 1 by 1. That is, first we are selecting a red ball 3 by 7, then without replacement 2 by 6. So this will be P of E1. So P of E1 value is 1 by 7. Then same way P of E2, both are black. So you have to find out how many blacks are there. 4 blacks. So it is 4 by 7 into 3 by 6. So that will come as 2 by 7. Again it can be done with 4C2 by 7C2 also. Without replacement can be done with the help of combination also. So 1 black, 1 red. So 3 by 7 into 4 by 6. And this should be multiplied with 2, because it can be red black or black red. So that's why we have to multiply that with 2. So that is also can be done with combination. So 3C1 into 4c1 divided by 7c2 into 2, that is the positions will get interchange. So that means the answer here will be 4 by 7. So these are P of E1, P of E2, P of E3. Now A given E1. A given E1 means we are drawing a red ball after 2 red balls are transferred. 2 red balls are transferred, we are drawing a red ball. So number of red balls will be increased by 2. In bag 2 we have to see. So bag 2 number of red balls will be plus 2. So that is 7 by 9. So bag 2, initially there are 5 red, 2 black. So when 2 reds are transferred, it will become plus 2. So that is 7 by 9. Now P of A given E2. Here plus 2 will go for with black balls. So number of red ball is still 5 only. 5 by 9. Then A given E3. Number of red ball is increased by 1. Total is increased by 2. So 6 by 9. So when you substitute all in the formula, the P of A answer will come as 41 by 63. So the answer is 41 by 63. Now the last problem. A bag contains 4 balls. 2 balls are drawn at random and are found to be white. What is the probability that all balls are white? So we have already selected 2 white balls, that will be A. So drawing 2 white balls. Now what are the partitions? So what is the probability that all balls are white? The bag contains 4 balls given here and 2 balls are we are drawing and we got white balls. What is the probability that all balls are white? So the probability, first one is bag will have only 2 white balls. Okay, bag contains 2 white balls. It will have minimum 2 white ball because we already got 2 white. Now bag contains 3 white balls. And last, bag contains all white balls, that is 4 white balls. Now as per the question we have to find, we already got 2 white balls, what is the probability that all are white balls? So using Bayes theorem, P of E3, P of A given E3, that will come in the numerator. Then 3 partitions are there, P of E1, P of A given E1 plus P of E2, P of A given E2 plus P of E3, A given E3. Now about P of E1, that is bag has 2 white balls and bag has 3 white balls. So it is 3 different types of, bag has 3 different types of conditions. So each will have same chance. So it will be 1 by 3. Bag is having 2 white balls or bag is having 3 white balls and 4 white balls. So it will be P of E1, P of E2 and P of E3 will be 1 by 3. Now P of A given E1. So bag has 2 white balls and out of that probability of selecting 2 white balls. So it will be 2C2 by 4C2. 2C2 by 4C2. Again at random, that's without replacement. So it will come as 1 by 6. So 1 by 6. So it can be done separately also, 2 by 4 into 1 by 3. Now P of A given E2. So number of white balls is 3 here. So 3C2 by 4C2. So that is 1 by 2. So again 3 by 4 into 2 by 3. So that way also without using combination. Then P of A given E3. That means all are white, the probability of getting white ball it will be 1. Now if you substitute all the values in the formula, E3 given A, the answer will come as 3 by 5. So the answer is here 3 by 5 for this particular problem. So that's all for problems from probability. Thank you.